All right, welcome back, welcome back, welcome back. So now what we're going to do is we're going to take this and we're going to start to animate some color. So how do we do that? And we're going to use this LFO to drive this animation. First thing we're going to do is we're going to go to Rec 1 main and let's change our fill color back to white. So that way we have 111 and all our color values, which will be better for the math that we're going to need to do. Then also, for temporarily, we're going to go to our transform one main. And if you don't have it open, you can hit the plus button next to translate to get the Python references. And we're just going to switch those from expression to constant. Okay, so now you should see a white rectangle, right? White rectangle in the middle of your network. Okay, so we want to see what these colors are going to do as we manipulate them. Okay, so now what we're going to do is we're going to take let's add some more real estate in our motion network box. Okay, and I'm going to actually close our viewer a little bit, make it a little smaller. Okay, so we have our LFO motion here. And what I want to do here is I'm going to add a select chop. Okay, so we're just essentially just creating another branch. Okay, and right off the bat, you can tell some things. So if you look here in our lag one, we have values going from say like 0.2 to negative 0.2. However, for us, we're going to use this for color. So the first thing we're going to do is we're just going to rename this color LFO. We're going to rename our channel LFO color. Okay, so now we know that this is different than the LFO that's driving the motion, right? Okay, now from there, what we're going to do is we're going to add a math. And what we want to do is we want to set our color value ranges to go um, from the negative values. We want to basically remap them to go to 0 to 1. So it looks like we're generating somewhere from like 0.22 to negative 0.22 to 0.22. So we're just going to go minus 0.25 to 0.25. Okay, so now you can see that we're essentially mapping from 0 to 1. Okay. All right, now that we have that set, what we can do is we're going to branch off again. So let's call this math to color. Okay. Once we have that, we're going to use our select chop again. So we could take a select here. We're going to take another select. And we're going to add one more select. If you're guessing that these are going to be the RGB values, then you're right. So what we're going to do is we're going to name select 2, color R, select 3, color G, select 4, color B. What we're also going to do is we're going to rename our channels. Okay. So let's call this rect1 color R, rect1 color G, rect1 color B. So if we zoom in, now you can see that we have 3 select chops, and we have branched them off. So it's still driven by this initial LFO chop, but we've remapped them now. So all the values go between 0 and 1, okay? And then we've split that into essentially 3 separate signals that we can then map. Now, what we're gonna do here is we're gonna use some maths, and we're gonna use some maths to have these values move at, actually, you know what? Instead of using a math, let's go ahead and we're gonna use a speed chop. Nope, I changed my mind. Instead of using a speed chop, let's go back. We're gonna use a math chop. We're gonna use a math here, and we're gonna insert another math, and let's insert a third math. Okay, so again, we're gonna rename here. So we got this math 2, let's call it math 2 color R, math 3 color G, math 4 color B. Okay, now what can we do to shift these so they move a little bit differently? There's a variety of things we can do. So just for the purposes and the scope of this lesson, okay, so what we're gonna do here is we're gonna go over to our math 3 color G. We're gonna add a pre-add of 0.2, okay? And then go to your math 4 color B and add a pre-add of 0.2. And then we are going to remap our range. So instead, we're going to go from 0 to 1.2, and let's map that just 0 to 0.5. So we'll clamp this range a little bit. And then we're going to go from 0.5 to 1 in our math 4 color B. And let's change that from 0.2 to 1.2. Okay, so we've set these 3, and now what we're going to do is add a merge chop. So we have a merge chop here. We're going to wire all 3 operators, your R, your G, and your B. So you should now see 3 values moving between different ranges. So what I have here is I have your rect1 color going full from 0 to 1. We have the rect1 color G basically going from 0 to 0.5. And then we have the rect1 color B going from 0.5 to 1. What we're going to do here is we're going to add a constant chop, and this constant chop will just hold our values. So we can null out our merge. All right, I'm going to call this merge 1 color. Get our name right. We'll call this null 3. Null 3 color. And then we can take those values and place them into our constant chop. So this is what I'm going to do. I'm going to make the viewer active for our null 3 color. Select constant 1. We're going to add 3 channels. And then I'm going to take the rect1 color R and export the chop reference into channel 1. I'm going to take rect1 color G. Let's export this into channel 2. And then the third one into channel 3. We're going to rename these channels to the same thing, color R, rect1 color G, rect1 color B. So now we have a constant that's holding the LFO. We've manipulated this LFO. It's the same LFO that's driving our motion. And let's call this constant 1 color. And now we can take these color values and connect them to our rect1. We could have it drive the color values directly, or we could have it compose. So what we're going to do here is, for simplicity, just to show you how we can connect very quickly, we're just going to take our fill color and we're going to take the 3 values and export. The RGB, and now you can see how our LFO is pulsing a very smooth color change in our rect1 main. Okay. Then the final thing we're going to do is we're just going to take our transform here and we're going to turn back on our expression and turn both of our expressions on. And now you have a shape that's animated both in the X and Y direction. And we're also animating the color of the shape with the same LFO.